This video is going to cover the measures of spread when describing a distribution, and the first measure of spread is the range of a dataset. So the range is the difference between the highest and the lowest value of a dataset. And if we look at the same data from our measure of center video, notice that the highest and the lowest value are 14 and 2, and if we take the difference, we find that the range is 12. Now, one thing to note when discussing the range, let's say we have an outlier in our data set. The new highest and lowest value would be 102. And so if you subtract these two values, we now have a range of 98. And because of this, we just want to note that the range is heavily influenced by outliers, and so it's not a common technique or a common statistic that we use when describing the spread. Instead, we can use the standard deviation, which is the measure of the spread of the data about the mean. And the standard deviation is related to the variance, which is just the standard deviation squared. And these are two statistics that you can use when describing the spread of any data set. Now, we're just going to look at the formulas for both of these statistics, and we're not going to calculate them in this video because it can be quite tedious. So you can tune into a later video to see how to calculate these on an actual calculator. Now, for now, I'm just noting that the standard deviation is given by lowercase s, and the sample variance is just that value squared. And one thing to note when discussing this formula is that both formulas are dependent on the sample mean, and this actually just tells us that both of these statistics are dependent or are influenced by outliers. And we typically use standard deviation because it keeps the same units as the units of the data set, whereas if you use the variance, you're going to have a squared unit, which is not commonly used when describing the spread of the data. So these are both used again if you do not have outliers in your data set. So what can we use when we do have outliers? We can use the interquartile range. So the interquartile range is the measure of the spread of the data about the median. So anytime you use the median to describe the center, you want to use the IQR to represent the spread. Now, how do we calculate interquartile range? If we have the exact same data set, this time note that all of the data is sorted the same way you sort it when discussing the median. And notice in the word interquartile range that we want to split up our data into 4 sections. So if you want to split the data up into 4 pieces, there are 3 cuts that need to be made. You're going to have a Q1, Q2, and Q3 cut. Now the Q2 or second quartile of your data is going to be the median of the data, and then your Q1 value is actually your lowest quartile, and it's the median of the lower half of the data set, not including the median. And then your Q3 is the median of the upper half of the data set, which does not include the median. So in this case, Q1 is 3, Q2 is 7, and Q3 is 9. Now to get the IQR, you just subtract Q3 minus Q1, and this gives you 9 minus 3. So our IQR, or interquartile range for this data set, is 6. Now, since the interquartile range is dependent on the median of the data, this tells us that it is resistant to outliers. So anytime that you report the IQR, you want to use the median to record the center, and these are both resistant to outliers. Also, we've mentioned the word outliers throughout all of the previous videos, and when we discuss the IQR, you can actually take the Q1 and subtract it from 1.5 times your IQR, and Q3 and add it to 1.5 times your IQR, and anything that falls outside of that range is going to be an outlier. So we can discuss this in more detail in our video on box plots, and that will be something that helps branch out on this idea of the interquartile range.